Hi, this is Professor Prakash. In this video, we will discuss Russell and Norvig's four categories of AI definitions. Russell and Norvig have referred 8 textbooks for artificial intelligence to define it precisely and have proposed four approaches. Until now, we have claimed that AI is exciting, but we have not said what it is. Definitions of artificial intelligence according to 8 textbooks are given in the following table. Let us look at these definitions one by one. First approach, systems that think like humans. According to Hogland 1985, AI is the exciting new effort to make computers think. Machines with minds in the full and literal sense. While Bellman in 1978 defined AI as the automation of activities that we associate with human thinking, activities such as decision making, problem solving, learning. Second approach, systems that think rationally. In this, the Chamiak and McDormand in 1985 wrote that AI is the study of mental faculties through the use of computational models. However, Winston in 1992 said that AI is the study of the computations that make it possible to perceive, reason, and act. Third approach, systems that act like humans. In this approach in 1990, Kurzweil defined AI as the art of machines that perform functions that require intelligence when performed by people, while Reich and Knight in 1991 defined it the study of how to make computer do things at which at the moment people are better. Fourth approach, systems that act rationally. In the fourth approach, Poole and his team in 1998 had defined AI as the computational intelligence is the study of the design of intelligent agents. And Nielsen in 1998 defined AI as it is concerned with intelligent behavior in artifacts. These definitions vary along two main dimensions. Roughly, the ones on the top are concerned with thought processes and reasoning, whereas the ones on the bottom address behavior. The definitions on the left measures success in terms of fidelity to human performance, whereas the ones on the right measure against an ideal concept of intelligence, which we will call rationality. A system is rational if it does the right thing given what it knows. Historically, all four approaches to AI have been followed. As one might expect, a tension exists between approaches centered around humans and approaches centered around rationality. A human centered approach must be an empirical science involving hypothesis and experimental confirmation. A rationality approach involves a combination of mathematics and engineering. Let us look at the four approaches in more detail. Thinking humanly, the cognitive modeling approach. If we are going to say that a given program thinks like a human, we must have some way of determining how humans think. We need to get inside the actual working of human minds. There are two ways to do this through introspection, trying to catch our own thoughts as they go by, and through psychological experiments. The interdisciplinary field of cognitive science brings together computer models from AI and experimental techniques from psychology to try to construct precise and testable theories of the workings of the human mind. Thinking rationally, the laws of thought approach. In the laws of thought approach to AI, the whole emphasis was on correct inferences. Making correct inferences is sometimes part of being a rational agent because one way to act rationally is to reason logically to the conclusion that a given action will achieve one's goals and then to act on that conclusion. On the other hand, correct inference is not all of rationality because there are often situations where there is no provably correct thing to do, yet something must still be done. Acting humanly, the Turing test approach. The Turing test proposed by Alan Turing in 1950 was designed to provide a satisfactory operational definition of intelligence, rather than proposing a long and perhaps controversial list of qualifications required for intelligence. He suggested a test based on indistinguishability from undeniably intelligent entities, human beings. The computer passes the test if a human interrogator, after posing some written questions, cannot tell whether the written responses come from a person or not. Note that programming a computer to pass the test provides plenty to work on. The computer would need to possess one of the following capabilities, even I say all of these capabilities. Natural language processing to enable it to communicate successfully in English. Knowledge representation to store what it knows or hears. Automated reasoning to use the stored information to answer questions and to draw new conclusions. And machine learning to adapt to new circumstances and to detect and extrapolate patterns. Turing's test deliberately avoided direct physical interaction between the interrogator and the computer because physical simulation of a person is unnecessary for intelligence. However, the so called total Turing test includes a video signal so that the interrogator can test the subject's perceptual abilities, as well as the opportunity for the interrogator to pass physical objects through the hatch. To pass the total Turing test, the computer will need computer vision to pursue objects and robotics to manipulate objects and move up. These six disciplines compose most of AI, and Turing test deserves credit for designing a test that remains relevant 50 years later. Acting rationally. The rational agent approach. An agent is just something that perceives an act, but computer agents are expected to have other attributes that distinguish them from mere programs, such as operating under autonomous control, perceiving their environment, persisting over a prolonged time period, adapting to change, and being capable of thinking on another goal. A rational agent is one that acts so as to achieve the best outcome, or when there is uncertainty, the best expected outcome. I hope you understand the four categories of AI definition. That's it for now. Stay tuned for more. Thank you.